for the last session for today. And today it's a kind of portfolio reporting day, at least at this point in this room. And today we want to take a look on the hosting of Metadb. This is the successor of LDP, which several institutions runs already. And we will take a look on best practices, how to host that. And I'm Axel Dörrer from Mainz University. I'm not hosting at this point. I'm not in production at this point, but I'm involved a lot in the reporting sake and with all the things. And the speakers today is Naseeb Nisar from Index Data. He is the mind behind LDP and Metadb, and so he will be enlighten us with all the things, what to think about on that. And on the other side, we have Jason Root. Thank you for participating. You too, from Texas A&M University. He is the SysOp guy in Folio, kind of. And he will talk about the LDP setup he has, and we will have then in this agenda, we will at first Naseeb will talk about the Metadb environment, and then we will have a tech talk about how to migrate the LDP to Metadb, and then we'll see what questions we have afterwards. At this point, I want to hand over to Naseeb. See what you want.
Thank you, Axel. First I have to apologize because the person that was supposed to be here was Index Data DevOps, and somehow the wires got crossed, and so we couldn't get a DevOps today. And I'm not a professional DevOps, so what I thought I would do is run through a few examples of some of the configuration, some system requirements, things like that. And I'm sure that will generate at least a few questions and sort of give you a starting point. There's also a fairly complete documentation on all of this for Metadb. So, those of you who are in the morning session have already seen this and will have heard a few of these things. So I'm sorry if there's duplication. So my thought was that the audience here would be sort of DevOps related, people interested in that sort of thing. So I thought maybe just starting with the architecture. Again, basically you have Folio or reshare, or the database that sits behind Folio or reshare and maintains at every moment the current state of the system. And what we'd like to do is to capture the data here and changes as they're made and feed them up so that they end up in the Metadb database. So the various components, this already exists. And let me jump to Kafka. I think everyone maybe knows what Kafka is. They call it an event store. It's a kind of database that models queues, a set of queues. So what happens here is that data or changes to data end up in queues, and there's one queue per database table, as we're down here. And every change then is a change event, which gets put on the queue, and Metadb reads from the other end of the queue. So usually it takes at least a few seconds for data to flow all the way up. But that's the basic idea. The changes are captured using a change data capture, which is the general concept. Since we have some DevOps people here, maybe I could get into a bit more detail. But different databases implement change data capture in different ways, but the basic idea is that it gives you a way to connect to the database and find out about any changes made to the database or certain kinds of changes made to the database as they happen, more or less. And the way that Postgres implements this, they started out implementing it for their own replication scheme, and later they opened it up so other applications could connect to it. In Postgres, when you make changes, they're written to something called log structured data, which is they call a write-ahead log. And it's because they write the data there, and then every once in a while, after a certain time maximum or disk space maximum threshold has been exceeded, it does a checkpoint. The checkpoint then writes all those changes into the tables, updates all the tables. So the way that Postgres implements its change data capture, which they call, which is replication, or the newer term for this general thing they call logical decoding. When a checkpoint happens, usually it erases the log because now the changes have been updated to tables. When you set up this logical decoding, Postgres creates something called a replication slot. And then it's sort of a logical concept, but some software, in this case, this software, connects to the replication slot and can read data from there. So what happens is that when a checkpoint happens in the database, instead of clearing away the log, it waits to clear the data until all of the readers of the replication slot have gotten the data too. And then, once everyone has seen the data, then that portion of the write-ahead log is erased. So here we have there's something called Kafka Connect, which is a connector framework for making it easier to produce data, to create data sources that feed into Kafka or that read from Kafka. And there's a project called Debezium, which makes change data capture connectors for different databases. And one of those databases is Postgres, which is a database system that is used by both Folio and ReShare. So basically, the Postgres connector is connecting to a replication slot here. So the very first thing to get this party started, you have to basically update, change one setting, I think, in the Postgres configuration to turn on replication. And that allows you then to create a replication slot. And it's actually the connector itself that creates the replication slot for you. Would it be okay if we say to the end, or if you think it's...
I'll just write down my question so that I don't forget.
Oh, sorry.
No problem.
Well, do you want to say it now, and I can come back to it?
I have two questions. One was the report is anywhere with the other one, if you have a topic to the table, how can you handle the kind of setup?
Oh, sorry. Yeah. Okay, so the first thing is Aurora, and the other is multi-tenancy. How do we make sure they don't cross paths? So that's really an issue of namespace, because in Kafka, all of the topics are there together. So we have to make sure that the namespaces don't collide. Namespaces are based on the tenant names, which can't collide because in Folio they could be shared there. But it's an important question because you wouldn't want to accidentally read data from the wrong tenant. So the other question about Aurora, we haven't tested it with Aurora yet, but recent versions of Aurora have added support for logical decoding. And in the sort of user community of Debezium, which creates the connector for this, they report that it's working. So in principle it works, but we need to test it. So So as changes occur here, just to make it concrete, a user is working with the Folio web interface and makes a change to a record somewhere or adds a new record somewhere. That generates a change at the database level. That change, it's sitting in the write-ahead log. It's read by the replication slot, and then placed into Kafka at the end of the queue. And then here it just sits in Kafka. Kafka is in a way like it's holding the data in escrow. And at some point, as soon as possible, MetaDB will read from the other end of the queue. And when MetaDB reads it, it performs various kinds of transformations. It retains the history, various things like that, and then writes the data to the database. And once they're successfully written there, it commits the to Kafka, saying, "Okay, I've got the data and it's safely stored." Now, if there's a breakdown, let's say there's a hardware failure somewhere here, usually not a problem because data are persisted in Kafka and they're not the mechanism that Kafka uses to remember where you are reading in the queue is not updated until the data are safely persisted above. So up here is fairly stable. It's possible that here, if you have a hardware failure, or if the connector fails in some way that it can't recover, it's possible that this stream breaks. And if that happens, then it's possible we could lose some change events. And the ones I would be most concerned about are deletions. So at that point, you have to do what's called a synchronization, which is to take another snapshot of the data and feed it all the way up, so that MetaDB can check if any data that we're deleting here have not been updated there. And then once that process starts, any changes again will be captured because they're basically sitting in the writing again. So I think that's a basic overview of that. So now I thought I might just give sort of starting with MetaDB, and because I'm not an expert on system administration of Kafka, but we're gradually adding that information from the DevOps that have had experience with it now in this context, adding that to the documentation. So hopefully there'll be plenty of more detail about this. But starting just from the top level of that, the MetaDB, their hardware requirements, there's some recommendations here which are based on a medium to large size library. That would be something like Chicago, maybe a large size library, and maybe Colorado, something like that. And then if you're building from source, there are a few software dependencies. Again, here the recommendations for Postgres are based on medium to large library, and it requires a Postgres 15 or later. This is for the MetaDB database, not for the Folio or Reshare database. That can be an older version. So if you're a DevOps person, you basically get the MetaDB software. This is how you build it. And then you create something called a data directory, and that's just a local directory located on the system where MetaDB is running, and or is going to run. And MetaDB will use that directory generally as temporary disk space. All of its persisted changes are persisted in the database itself, but this is more for temporary storage. So it creates a file called metadb.conf, and those are basically the database connection parameters. So you fill them in, And once you've done that, oops, and if this isn't the first time you're setting it up and you're upgrading MetaDB, you run this command and it will make any schema changes that are needed for the upgrade. And now to start MetaDB, it's MetaDB start, and you can give a log file name. There's also a log in the database itself, a structured log that's not as complete as this one, this is more for DevOps, but the one in the database is more for users, so they can keep track of, try to understand what's going on when things are getting updated, if there's some kind of data error in transformations, things like that, they can look there to actually find out information. And then to stop the server is just this simple command. You can optionally, you could set it up in systemd if you want. It's pretty straightforward. And then to actually sort of configure MetaDB itself, you connect to MetaDB directly. You have to be on the same system. It can only connect from localhost, but MetaDB emulates a Postgres server. So you can use PSQL, the normal Postgres command line client, to connect to MetaDB. This is to MetaDB, not to the MetaDB database. And then you can issue commands. Now, this is getting into Kafka Connect, the connector that reads data from Postgres. And this is not developed by us. This is software is created by the Debezium project. But this is an example of a connector, and there's a place here where you can create a sort of a unique prefix for the Kafka namespace for the topic names. Let's see if there's anything interesting. There's a recommended to use a heartbeat query that will fire every once in a while to make sure that the right head log is cleared away properly. And most importantly, at the bottom, I didn't actually give the examples, but you can provide regular expression that tells the connector to exclude certain schemas and certain tables. So if there are tables that you don't want to stream up to MetaDB, you can do that. And there are some recommended or suggested settings for that in the documentation. So this is sort of the configuration file that you create, and you send this, you basically post it to the Kafka Connect, and it creates the connector, which then creates the replication slot and begins streaming data. Now, because the write-ahead log keeps growing until it's read, if there's some kind of failure at the Debezium level, it can continue to grow and grow and grow. And it's depending on how much free space you've allocated in Folio or Reshare, it could fill up the disk. So it's very important to monitor this replication, what they call replication slot lag. And this is a query that does it, but if you're using AWS, RDS has I'm not sure if it's in CloudWatch or where it is, but there is actually a pre-made monitoring script or something that does this for you, so that it can be added to the monitoring dashboard. And now to actually tell MetaDB to read from Kafka, you connect to the MetaDB server and you use these sort of SQL-like commands. This is not something that's supported by Postgres, it's specifically MetaDB, but you create a data source. This one is for Folio, so we just call it Folio. And then there are some parameters there. These are detailed in the documentation, but I could answer questions about them later. But here again, there's an opportunity to filter out schemas and tables. If you want to be extra sure, you can filter them both places. But there's schema stop filter, there's a table stop filter, and then we'll add pass filters as well, so you can get more fine-grained filtering.
Before you move on, then that term schema prefix where you have tenant name in a multi-tenant environment, I would assume you wouldn't want to do that, right? That goes to Mark's question about multi-tenancy.
Well, the Metadb itself is not multi-tenant.
Okay.
So you'd set up one of these for each tenant.
Got it. Okay.
And each tenant will have their own Metadb database, so they can't wander.
Understood. Thanks.
Yep. And for reshare, there's sort of an added step where you want to tell it about the tenants so it can properly sort the data and do the combination. I guess I described this in 2 talks already. I probably didn't today, but don't think anybody here is hosting reshare, so maybe I don't need to go into this. But the basic idea is that reshare is a consortial sort of deployment of, it's based on Folio, and it uses Folio's multi-tenancy for individual tenants within a consortium. And so if you're something like reshare is not actually all of the library's data, it's just the resource sharing data for the consortium and for each library within the consortium. So let's say, like in reshare, you have a patron request table. In reshare, because it's using Folio's multi-tenancy, then each tenant gets its own patron request table. And so what Metadb will do is combine them all into a single patron request table and a column called origin. And origin contains the name of the tenant. So just to make it very easy to do SQL querying across some or all or one tenant. And so for each tenant, you create a data origin so that Metadb knows about it and understands what it's dealing with. Now, when you first start the streaming going, it begins a process called synchronization. And after some time, and what that's doing is reading a complete snapshot of the source database. And once that's done, it will put something in the log that says synchronization is done. And so right now, it's not integrated as part of the server. So you actually have to stop the server, and then you run Metadb nsync to tell it now we're finishing the synchronization, and then it will clean up any data that has not been confirmed from the new snapshot. And then finally, you restart the server and you continue. If for some reason you have to do a resynchronization because there's a failure at those lower levels, the process is very similar to this, except you have to start the synchronization explicitly, and the command for that is metadb sync, and then the rest is the same. So you do that at the beginning, and then stream the snapshot, and then do an nsync. So MetaDB users are basically Postgres users, because users are connecting directly to Postgres. But MetaDB does some extra things like setting up a kind of environment for users. So one of the things it does is to create a schema for each user, and that's a personal workspace for that user. And so you can use that users can use that to import external data from somewhere other than Folio or Reshare, from anywhere, to create tables or to save the result sets from queries. And you can also to create reports, and then you can also share those things with other users. So so in order to set all of that up, instead of creating the user in the database directly, you connect to the MetaDB server and create the user there, and that will take care of the setup. And then to give the user permission. Right now, it's just a binary thing. You give them user permission to all the tables. But one of the upcoming things on the roadmap is to have granular user privileges. But if you just do a grant, then grant privileges in Postgres, you won't know about new tables that appear later. And so this is an Metadb command, authorize, which basically says any tables that come about from the this shouldn't be sensor, this should say folio. It's from another example, sorry. But any other tables that come from that data source, you're authorizing this user to access them. That's all I had. Yeah, please.
Metadb server comes close to Metadb itself. So users want to query the database. Do they go to Metadb server using its APIs, or do they go against the Metadb database itself?
That's a very good question. They go directly to the database. And in fact, you cannot connect to the Metadb server unless you're on the same node. It only accepts connections from localhost. There's no other way into the Metadb server. So Metadb is managing the permissions, managing everything in the database. The users connect directly to the database. So they're dealing with Postgres directly. Other questions?
No other questions?
Any online?
Perhaps any online? Check chat. No questions right now. So I think we can move over to the second part of this session, and we want to talk about migrating LDP to Metadb, and perhaps it's good to have first a glance on how Metadb is set up, or how LDP setup should look like or could look like.
Right. So we at Texas A&M have, I'm going to use this one. We have self-hosted ours, right? So I'm going to bring up real quickly here, kind of an overview of what it looks like on infrastructure. We've been running the LDP since the initial version 1 came out. Typing with one hand here, so it's a little slow, sorry. No, you're good. You can exit the thing. Yeah, there we go. I'm going to set the mic down here while I do this. Yeah. Nope. I can spell my own name right. No, never seen it. All right, so believe it or not, this is what I look at every day when I run Folio and when I run LDP. This is our actual Folio production cluster. The reason why I chose this is because we do expose it outside of the firewall at A&M for other libraries like in Cutter and other places. So this is a quick, I'm just gonna slide through it. As you can see, Folio and LDP are a lot, right? There's so much here. I don't expect anyone to read all of this, but what I run inside of our cluster are the actual LDP jobs themselves. We have the LDP server, which we've containerized from the project we see has so graciously put all of the documentation out there. We pull that straight from their GitHub repo. We run the LDP data update artifact straight from their GitHub repo. And what we do curate here at the library is our own derived tables. Every institution has their own needs, their own requirements, their own queries. We derive ours from the community provided queries, and then we make special adjustments and all of that. And I will say, whatever you think you know about the reports that you run at your library, you don't. There's some librarian in a closet somewhere that has been running a report you don't know about until it's too late. And that might have been 2 years ago, who knows? So we're still actively finding reporting requirements and implementing into the system. So it's really nice for us to be able to host this ourselves and make those live updates. We have all of the environments, dev, test, pre-production, production, and we have the stakeholders come in and say, hey, does this report do the thing you needed to do? Okay, great. And I go update the drive tables, and now it runs nightly and they can do their querying. What is nice about this interface is you can see if they fail or not. And we do log ship all of this out. We have a Splunk instance that we aggregate. So if any LDP sync happens to fail overnight, you know, network, transient network issues, or the database volume fills up, we'll get an email or I'll get a Slack alert and it'll say, hey, I failed, and I can come in here and look at these little green blobs, and one of them will be red, and I'll click on it and see what the log says. I'm like, oh, well, that didn't work. I guess we'll have to wait till tomorrow, or I can kick it off by hand. There's a few lessons we learned when we set all this up originally, and that is that the syncs are very heavy. You know, we're not the biggest library in the world. We've got 4.6 million bib records, instances, and so on. But that still incurs a lot of time to do nightly, not only from the data sync, which is for us maybe a few hours, then the drive tables, which is another, you know, few hours, and then the markup data in between. If it's an incremental, minutes. If it's a full update, a couple hours. All told, our nightly update goes on about 10 to 13 hours, just depending. The first job in here is the LDP data update job. It kicks off around 6 p.m. And the last one that happens is this derived update job. I can click on it, and you can see it completed 13 hours ago. So that was what, 7 o'clock this morning or something like that. I'm bad at math right now. I'm still jet brained. But you can see here, you know, it tells me what time it ran, what node or cluster it ran on, so on and so forth. So because of all of this data and all of this time it takes, network latency matters. And what we decided to do was run the LDP database in the same physical data center that our Folio production database runs in. So the nightly syncs don't have to go through so many hops. It doesn't leave the data center. It doesn't even leave our rack. We've talked to other institutions who run LDP in the cloud, and we recommend, you know, if you've got a region with a data center somewhere, you know, US East 1, blah, 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 wherever that is, run your LDP also in that same space. You will save yourself a lot of heartache and time trying to figure out where my network connectivity was interrupted, and now I have to redo the whole thing over again. So the instance types, and see it had up earlier. I wish I had a slide for that, but I don't. Ours are about double what the default recommended is. So our main LDP database is an 8-core, 32 gigabyte system. It has, I think, a terabyte of disk space available for the database growth. And, you know, we back all of that up nightly. Also, preferably not during the same time we're running a sync, so you can really slow down storage that way. But every now and then they overlap and things go a little slower. All of that being said, we have not moved to Metadb yet. 2 reasons. One is I don't have a database administrator working at Texas A&M right now. So I'm running all of the databases for Folio and LDP, and I'm not a database administrator. So there's a lot of special expertise and knowledge in there that could really help us craft what our queries need to be, what types of indexes and tables and whatnot, you know, we need to create ahead of time. And that person's not me. The other side of this equation is we have a lot of homegrown reports. We have a lot of canned homegrown reports and a lot of, I'm a librarian and I need this data to go make my other homegrown report that then you need to host for me. And all of that takes a human cost, time management, change management. And We're still working on getting all of our reports put into the system for use by the libraries at large. And we've been on Folio for 1.5 years now. So it was a lot of work just to get us to this point, and it will be a lot more work to get us to Metadb. And I'm really grateful for Nasib over here, because anytime I have a question or a query or something happens, help me out, he's on the spot for it. I appreciate that a lot. He's really good at the feedback. And I'm going to hand it over to Nasib, kind of knowing now what our infrastructure may look like, how you would recommend moving all of this maybe to a Metadb system. So we'll go from there.
It's well,
You don't need this up anymore.
Yeah.
Okay, I'll walk it up.
Again, I'm not really a professional DevOps, but from what I've seen in our hosting operations, it seems that maybe the easiest way to do this is to stand up a Metadb system side by side with LDP for some period of time, and say, okay, you have 3 months or something to move over, and then and so they're totally independent. And then, you know, once it's moved over, the main thing you might want to get out of LDP is the 2 things would be historical data, which in LDP are all contained in a single schema. So you can just do a dump of that schema. And the other thing is there's a schema called local in LDP, which is a shared area where users can create tables and that sort of thing, reports. So maybe moving that over as well. And fortunately, those are all contained within those 2 schemas. In Metadb, we have those individual workspaces. So but LDP is simpler in that sense. So I don't know how much that covers.
No, that's a good start point. Our other, I'm not going to say an advantage, well, it kind of is, we're one institution and one tenant. And so all of this is much more easier to logically spell out during any kind of migration or setup or, resync and whatnot. And I'm not a German institute or European institution, so I don't care about data anonymization. Like, we want, our librarians want the full data for as far back as they can get it for whoever they can get it for. And so we don't redact any of that stuff out of the database. Same thing with like financials and whatnot. So all of the cross tenant gotchas, we don't have to think about half the time and worry about. But I know, a lot of consortiums and hosting providers, they have the multi-tenancy aspect to worry about. And I've going back on the migration part. So we also run our own Kafka instances. And we have a whole Kafka cluster dedicated just to Folio. Would you recommend a whole other separate Kafka instance for this, or do you recommend using what you already have? I don't know what the kind of the IO or the bandwidth looks like for the streams. I know also, again, in the cloud, there's 2 big costs. One of them is the database, and the other one is another database, which is Kafka, because that's what it is. So I know those are some considerations that I'll ask you about.
I would recommend starting out with a separate Kafka instance, unless your DevOps are Kafka administrator experts, if they really understand that, how to manage, manage different retention policies and make sure you're not having any impact from one system to the other, because in principle, Kafka is really designed to scale, and there's a good argument for just making a single Kafka instance, if you just want to be sure that you have quite a bit of experience. I think that would mention first.
That's good to know. And
on the on the multi-tenancy, I'm not sure if it was clear from the slides, but the namespaces in Kafka are managed entirely sort of on the back end of that. So when you're setting up the Kafka Connect, that connector setup, you're actually giving it the prefix of the topics. And so, it's the configuration of the connectors where you actually manage those namespaces.
And that tends to be the tenant ID, and with the folio data, right? Yeah.
Yeah, I'm glad you mentioned retention periods. 'Cause I was going to ask about that. So, what is your recommendation for how long should you retain this? Because if you retain them all too long, then you're wasting money essentially, right?
That's a great question, and I don't know the answer because our DevOps did handle that, and I'm not up to date on all of the details. And also, I think they are running separate. They're running a separate Kafka instance for these, so that makes it. It's still important because you don't want to run out of space before Metadb has read the data. That generally isn't a problem because from experience, the size of the folio database, so that the size of a snapshot. When you do a snapshot, everything is also incremental changes that change very slowly. So part of me thinks maybe I don't know the answer. Maybe none of us know the answer for if Kafka is being used for multiple purposes. But I could get you an answer from the DevOps if you're just using Kafka only for Metadb. And the Kafka instance, like if you use MSK in AWS, it can get expensive if you hit a certain threshold of topics. We haven't run into that with Folio, but we ran into it with vShare because in vShare, every tenant has its own set of tables. Every one of those tables gets a new. So if you have 60 libraries in your consortium, then you have to multiply the number of tables by 60. That's the total number of topics. You hit a threshold, it gets extremely expensive. So for vShare, only for that reason, because the DevOps prefer to use MSK, then we've scaled back a lot of the tables. We're just focusing on the main tables.
So like you, I'm not a professional DevOps. I'm on the dark side, in management. So my questions are going to be related to that. One is, in the previous session, you mentioned that to migrate from LDP to Metadb, you need to change the table name prefix, right? Are there any tools that are being provided to help with migrating LDP reports? I have a bunch of questions actually. So that's only the first one.
Okay. I'll try to remember. Oh, I can come to you. You may have better ideas of how to do this than I do. The only idea I've come up with for that would be to write a parser, or to use a SQL parser and modify it to make those changes. I don't think that would be too difficult, but this whole project runs on a shoestring budget. Thank you. So we don't have. So we have to prioritize this kinds of things, and because Metadb's happening still relatively early in the course of people's use of LDP. Of course, Cornell is affected, Chicago is affected, but a lot of the larger libraries that bring a lot of reports are just coming online with their community and not really haven't done much with LDP yet. The other thing is that although I made it look easy to report those queries, there are some other decisions you may want to make because the queries may rely on derived tables, which are not as up to date as the main tables. So you may want to see the queries to actually do the joins. in general, in terms of the costs, though, I wanted to mention, I mean, that the Kafka can be expensive. You need to know a lot about the administration of Kafka to sort of fine tune it, but you learn that over time. Apart from that, the resource usage goes down a lot when you move from EZP to Metadb because it's not reloading the entire folio database every night. So it's much smaller load than the database. Just an incremental update.
Sorry, I'm not wise to I'm asking questions. So if there are people.
There's one in the chat that asks about running multiple MetaDB servers for HA, and if that's a requirement or recommended or yeah, and that's I will say, like, for my standpoint, running LDP, we don't, our LDP server is essentially a task that spins up the compute, does what it does, and shuts down. And if it fails, it does it again. And if it fails, it keeps doing it until it succeeds. So for us, we don't run more than one LDP server per folio environment. It's just a compute task.
So
oh yeah. I don't know if there was the mic over here, like some of the rooms. So from our side on the LDP, we do not run LDP servers in HA. We have one LDP cron task that spins up the compute, does its thing, spins down. And if it fails, it does it again until it succeeds eventually. And each of our folio environments, we have 4, have their own LDP task. And it's a small container with some mounted storage for the cache space, what have you. And from what I've seen from what Nasib's presented, I wouldn't assume anything different. I would just assume, one MetaDB server with, per instance. But
I haven't thought about this a great deal yet because we're just still now wrapping up kind of the development of the basic features. But the architecture does take that into consideration to some extent. So there are two different kinds of high availability here. One is access to the reporting system, and the other is the latency for the updates. So anytime, because users are connecting directly to the Postgres database, that's usually available. The high availability there is the Postgres database. So you can have what AWS calls read replicas. You can use replication. So if there are problems somewhere in the architecture, at least users can still get to the data that have been updated. But then the question about what happens about updating the data, what sorts of problems can occur. And one thing that helps a lot is that the data are persisted in Kafka, which is sort of the middleman between the two. And so Kafka allows you to do redundancy. Our DevOps use that. They turn on redundancy for Kafka. So at that level, you have high availability, and then connecting from Metadb. Again, there's a sort of transactional nature of those updates. So they're kind of the data and the offsets are preserved in Kafka until they've been successfully written to Metadb. And Metadb itself is just a simple server process. So if you have to restart it, that's a pretty good thing. So it's a question of, I think, it has to do a lot with where the data are and which components, but there's sort of 3 stages. There's the folio reshare at the beginning, there's Kafka in the middle, and then there's the Metadb that's called. In between those are just software that's moving data from one to the other.
There's some questions in the chat. At some
It's just a question, but he's mentioning that Metadb seems to be running constantly. So, but I think that's already covered. Well,
So, I mean, right, so I'm not sure if I completely understand all the facets of this question, but you know, Metadb in a sense is just a middleman between these two databases, the Kafka database and the Metadb database, and you can look at high availability for the Postgres database. You can look at high availability for Kafka. Kafka has more features for that, you know, below that, that's the area I think that you have to be careful about the replication system, and just to make sure that you're monitoring that. I think this is the kind of question where I would like the DevOps to be here.
okay, thank you. I think this was from the questions from online, but Mark is still
What happens if you upgrade Folio? How does the system react to those upgrades? And then the follow-up question, so we talked about messaging young one. How do we clone the seed so that as we get more institutions adopting Metadb, it's a mission critical application kind of thing, right? Mission critical.
Absolutely.
And so if there's a problem, then how do those problems get addressed?
So there's been work recently on community and funding, because it's really, you don't need to clone me, you just need to hire more people. So that's actually beginning finally to make some progress, and so it looks like there will be some funding to help with that. We also have somebody in Index Data who's becoming more involved with the development. And I'm sorry, what was your first question?
Upgrades.
Upgrades. Oh, upgrading Folio. So as far as I know, there's nothing too there's nothing too extreme about Folio upgrades for the most part. So in principle, you can just leave the stream on. But I've seen our DevOps, if they run into a problem, they kind of wonder if there's, they're trying to reduce the number of variables of what might be a problem they're upgrading. So sometimes they will delete the replication slot, recreate it, and do a resync. Especially for smaller libraries, that's pretty quick. That works okay. But as far as I know, and I'm not aware of anything extreme that Folio upgrades do that would interfere with this.
I think the main consideration there is the data sort of upgrade scripts. So typically with Folio upgrades, you get something like, oh, now this new field is required, or something needs to happen in the database. So if you have millions of item records that all need to get a unique barcode or something like that, well, that would cause a lot of changes. I think it would introduce some latency, right? So beyond that.
Yeah, latency is not really a problem, because I think at least at Index Data, when we're doing a Folio upgrade, everybody expects to, there are going to be some temporary anomalies. So, yeah, but the thing I'm not sure about is if there's something more than we see. I've never actually seen anything specific. I've just seen that. I mean, it's possible. I can give you an example of something that could be a problem. If a table is not, so schema changes are fine, but if a table is updated by, I think Folio upgrades do this usually, but by dropping the table and recreating it, And then, let's see, actually, that's okay if you use inserts, but if they use a copy, for example, that might not be captured by the replication system, because copy bypasses the write ahead completely. That's how it gets its speed. So in those cases, what you can do though is you can go into Folio and just like first check the triggers on the table to make sure this is safe, but it always is in Folio as far as I've seen. You could say update this table set ID equals ID just to touch all the rows and they'll get transferred. So
I'm just wondering, you know, to get around some of the problems with surprises in changes to the data model, we went to a setup where we have LDP test and LDP production. I'm just wondering, would the same thing be useful for Metadb?
you also have a test and production folio.
Yes.
And so your test folio has test LDP and your production folio has it. So your production folio has a production LDP.
Yes, and you change the pointing depending on what you do to get the data. Yes. Sometimes it's better to get the data from folio production for our test. Sort of sometimes it's better to get the test depending on what we're playing.
I think that would be fine. Let's see. If you were doing both from the same folio instance, then you just have to be a little bit just aware that you'll be running two replication slots for two different Metadb instances, which could be confusing if you don't pay attention. But then DevOps, I mean, professional DevOps can handle all of that. It's a concern.
Okay, one last question, but we are on the top of the hour.
How many institutions are running Metadb in production?
If you're only counting folio, it would be 3 or 4, I think now. Because of the much lower resource usage, and because it's Metadb is more or less production ready now, there's sort of been a new decision at Index Data, Host Data to start moving everyone over from LTP to Metadb as soon as reasonably possible. There's also a whole lot of reshare users of Metadb. At least half a dozen, I think. Those are just reshare consortia. It's the reshare Metadb for reshare basically became production ready 2 years ago, and so it's being used in Metadb's been used in reshare for quite a long time now. Folio has a lot more data that gets right at the beginning when you install it. So there's there's the mark transforms and things like that. So it's just a more complex system, and so we've waited. It's been about 2 years to just make sure everything is working well, and then start to transition people over to Metadb. Yeah, okay, excellent.
Thank you so much for your attendance, and thank you for 2 speakers.
Thank you.
Thank you very much.